Thank you very much. One of the first things I started working on when I started at the ICCT 8.5 years ago was the issue of heavy fuel oil in the Arctic. And one of our crowning achievements as being part of providing some technical assistance to the Clean Arctic Alliance and also IMO member states is the Arctic heavy fuel oil ban that will start in July of 2024. And one thing I'll be talking about is its effect or lack thereof on black carbon emissions in its first iteration and what we can expect from that regulation in terms of black carbon reductions going forward. My presentation today will focus mainly on, well, it'll focus exclusively on black carbon emissions from ships, but we're also expert on the issue of methane emissions from ships. The use of liquefied natural gas as a marine fuel has been growing very rapidly. And in the Arctic, the use of LNG as a marine fuel was less than 1% of total fuel consumption in 2015. And the latest numbers that I have at top of mind are in 2019, it was a quarter of fuel consumption. And this is all related to Russian oil and gas development and the Yamal Peninsula project. But we've also seen a tremendous increase in the use of all fuels in the Arctic and black carbon emissions, which I'll cover today. So I'll talk a little bit about the trends and then break it down for you in black carbon emissions by the type of fuel that's being used, the type of engines those fuels are being used in, which has an impact on black carbon emissions, what kinds of ships, and what their flag state is, so what country their flag is. I'll also talk about that projected impact of the HFO ban on black carbon emissions. So I'm going to focus mainly on presenting our analysis of black carbon emissions that occur within the IMO's definition of the Arctic. And the IMO's definition of the Arctic is this blue line on the map here. And there are other definitions of the Arctic that are more inclusive, including what ICCT calls the geographic Arctic, which is represented by the edge of the purple squares on the screen. And then we have other even broader definitions of that. You can see on the map that a lot of the black carbon emissions, which is the darker colors on the map, the more the black carbon emissions, are actually occurring outside of the IMO's definition of what qualifies as the Arctic. So the IMO's definition of the Arctic in the blue area, if you consider all of the ships that are operating within this red circle, excluding the Baltic Sea, which we don't consider as part of the Arctic for this analysis, we're missing about 3/4 of the ships and about 3/4 of the black carbon emissions. And what's important about that is that the IMO's Arctic policies are only going to apply within this narrower definition of the Arctic. So there's some additional opportunities for policy action for countries that the ships are sailing to and from to establish additional requirements on those ships in order to reduce black carbon emissions that are happening outside of the IMO's Arctic definition. Fuel consumption and black carbon emissions have doubled in the IMO definition of the Arctic from 2015 to 2021. So we had about 200 tons of black carbon emitted in the IMO's Arctic in 2015, and now it's more than 400. Let me break it down to you in terms of engine type, fuel type, ship type, and flag state. So this is black carbon emissions that are emitted by ships in the Arctic, and each column is a different kind of engine. The left-hand one, which is the largest bar, is medium speed diesel engines. The speed is related to the RPM of the engine. And then we have slow speed diesel. These are gigantic engines, multi-story tall. They're not super common in the IMO's definition of the Arctic. The smaller, higher speed engines are much more common. We have high speed diesel. These are the smallest engines. They're already mainly using distillate fuels. So the different colors of the bars are different fuels. The blue are distillate fuels. Marine gas oil is one example. And then the orange portions of the bars are residual fuels. These are things like heavy fuel oil and very low sulfur fuel oil, which has been the norm since 2020. And then we also have LNG, which is the small slice. That's black carbon emissions from LNG, very low, but the LNG proportion of total fuel consumption is growing, as I mentioned before. This shows you the black carbon emissions by different ship types. So the largest contributor, about a third of black carbon emissions, are coming from fishing vessels. Most of these are already using distillate fuels. And the reason why I'm focusing on the distillate versus residual comparison here is that one of the easiest ways to reduce black carbon emissions by ships is to switch from the residual fuels to the distillate fuels. You can cut black carbon emissions in half for the medium speed diesel engines, which are the most common, and by 80% for the slow speed diesel engines, but those are less common, much less common in the Arctic. So the second largest contributor, and it's about a quarter of the total black carbon emissions in the Arctic, are from oil tankers, from oil and gas development. Almost all of these are using residual fuels, heavy fuel oil, very low sulfur fuel oil. So there's a potential here to reduce black carbon emissions from this source in particular, and also general cargo vessels. It may not surprise you to learn that Russia is responsible for most of the shipping activity and fuel consumption in the Arctic. And as a consequence, they are also responsible for the largest share of black carbon emissions, 10 times more than the next nearest country, which is Norway. And this is broken down by the flag state of the ship themselves, not necessarily who owns the ship, but what flag they're flying. 2/3 of the black carbon emissions, and you can see that a lot of the black carbon emissions are associated with using residual fuels. All right, and then I did want to touch on the impacts of the upcoming Arctic heavy fuel oil ban, which will start in July 2024. But there's a number of exemptions and waivers that really limit its ability to reduce heavy fuel oil use and carriage in the Arctic, and also therefore reduce its ability to reduce black carbon emissions. So what I'm showing you on this graph is we're breaking it down again by the engine types: medium speed diesel and slow speed diesel, total black carbon emissions. The bars that have blue and orange, that's the current black carbon emissions from distillate fuels and residual. And then the solid blue bars are what the black carbon emissions would be if all of the fuel consumption by that engine type were only by distillate fuels. And so the black carbon emissions from using residual fuels in a medium speed diesel engine can be reduced by half by switching to distillate, and 80% for the slow speed diesel engine. And if you were to convert all of the fuel consumption from ships that are operating in the Arctic from a mix of distillate and residual fuel just to 100% distillate fuel, you could achieve about a 1/3 reduction in black carbon emissions within the boundaries of the IMO's Arctic. So July 2024, we expect that the Arctic heavy fuel oil ban will reduce black carbon emissions in the Arctic by about 5%, starting in July of this coming summer. And the reason that it's not a larger reduction in black carbon emissions is because there's this 5-year delay in implementing the heavy fuel oil ban for ships that fly an Arctic flag. And I showed you earlier that Russia is the main contributor to black carbon emissions from shipping in the Arctic. They're an Arctic flag state, and so they're exempt from this regulation for 5 years. So this is true for any Arctic flag state, Norway included, Denmark. But the big benefactor here is Russia. There's also an exemption for ships that are newer for 5 years as well. And that primarily benefits bulk carriers that are serving the Canadian Arctic. like the Baffin Land Mine, and it also benefits oil and gas operations. So when we finally get to full implementation of the heavy fuel oil ban in 2029, summer of 2029, we expect a 30% reduction in black carbon emissions because it's going to force this shift from the residual fuels to distillate fuels. And we estimated it was about 34% based on 2021 numbers. This is 30% based on 2019 numbers. So we can generalize this to say that the Arctic heavy fuel oil, when it does finally enter into effect, will reduce emissions of black carbon by about a third. So just to sum up, black carbon emissions from ships in the Arctic are growing. They doubled between 2015 to 2021. The IMO's Arctic definition excludes 3/4 of ships and black carbon emissions in the broader geographic Arctic. Most black carbon emissions come from ships that are using residual fuels. It's about 2/3 of black carbon emissions. Russian flag ships also, they account for 2/3 of black carbon emissions in the Arctic, combination of burning distillate fuels, but mainly residual fuels. The Arctic heavy fuel oil ban that will go into effect next year is only going to cut black carbon emissions by about 5% due to these exemptions and waivers that impose a 5-year delay. And then the full implementation will cut black carbon emissions by about a third, according to our work. And then black carbon emissions outside the IMO Arctic will remain unchanged until new policies are developed. I wanted to end by saying that Marcus, who was just up before me, mentioned diesel particulate filters. We've had filter forcing diesel particulate filter standards here in the United States for heavy duty vehicles since 2007. You can correct me if I'm wrong on that. I think it's 2007. And we have no filter forcing standards, including domestically in the United States for marine engines. And we definitely don't have any at the international level. So the first prerequisite to getting filters on ships is switching over to cleaner fuels like distillate. And then we can work on setting standards that would actually have low particulate matter emissions requirements, low enough that we could actually get filters on ships, which we don't have really any true sets today. I want to thank you very much for your attention. I'm here, Ludmilla's here online. She did all of the analysis that you see presented here today, so I can see her on screen as well. And happy to take any questions that you might have. Thank you.